engine of a theoretical steam engine are are 0.5 meter and 2 meter long respectively. The crank makes 180 rpm in the clockwise direction. When when it has turned 45 degree from the 45 degree from the inner dead center inner dead center inner dead center inner dead center position, comma, determine determine number 1 velocity of piston, number 2 angular velocity of connecting rod, number 3 velocity of point E on the connecting rod, point E on the connecting rod, connecting rod 1.5 meter from the gudgeon pin, 1.5 meter from the gudgeon pin, number 4 velocities of rubbing, velocities of rubbing velocities of rubbing at the pins of the crankshaft, comma, crank and crosshead, crank and crosshead, crank and crosshead when diameters of their pins are diameter of their pins are 50 mm, comma 60 mm, 60 mm and 30 mm respectively. Comma, then number 5 position and linear velocity of any point G on the connecting rod which has the least velocity relative to crankshaft. Relative to crankshaft. Relative to crankshaft. Okay. statement everybody has written? Ajay?
Yes, sir.
Okay. Then on the basis of statements, you can write the given data first. Right? NBO. So before that, just I will show you figure. Okay. You can write this ENBO, that is crank speed 180 rpm, 180 rpm. From that, we can calculate omega BO. Just refer this diagram. After this VBO, we will see how it can be drawn. Omega BO 2 pi En divided by 60. So 180 rpm, that is given. So from that, we can get the value of this angular velocity in radian per second. So crank length, it is given 0.5 meter. Crank length is given 0.5 meter. So here it is given crank and connecting rod. Crank 0.5 meter and connecting rod 2 meter long. Then here you can add connecting rod. You can add here connecting rod. Is equal to 2 meter. Okay. Okay. Then linear velocity of this B with respect to O. You can write this VBO is equal to VB is equal to omega BO into OB. Up to this completed? Ajay, up to this completed?
Yes, sir.
Up to this completed, Ajay?
Yes, sir.
Okay. Now Based on the statement, we need to draw the space diagram. So first of all, then you can draw. So first thing, we need to find out this velocity of piston. So velocity of the piston, so this we need to find out. So you can write as velocity of piston. So this one is the piston, we need to find out its velocity. So for that, first of all, we need to draw the space diagram. So first step, first of all, draw space diagram to some suitable scale as shown in this figure. Okay. Now we know this is 2 meter, this one is 0.5 meter, here it is given. So largest dimension is 2 meter. So we need to use scale that should be workable with the space available on the sheet. So we can take 1 centimeter is equal to 0.25 meter. So based on that, for 2 meter we can have 8 centimeter. The length that needs to be drawn for this BP, that is the connecting rod. So accordingly, we have selected 1 centimeter is equal to 0.25 and everybody should take this scale. Then OB, this is the crank. So crank length is given 0.5 meter. So 1 centimeter is equal to 0.25. So for 0.5 meter, we can have 2 centimeter length. And for connecting rod, 2 meter means for this BP, we can have 8 centimeter length. And you know, this crank is going to rotate like this. So just crank is going to rotate like this. So whenever engine is placed horizontally, so just this one is inner dead center and this one is outer dead center. So when crank will have this position, then the piston will be at this end. So therefore we are going to consider this point as the inner dead center. So crank, when crank will be at this point, so we are going to consider the crank is going to move like this and it is going to make the 45-degree with the inner dead center, angle 45-degree with the inner dead center. So then with respect to this velocity of piston, angular velocity of connecting rod, then velocity of point E. So they have determined the position of this E and determined the position of G. So the linear velocity, position and linear velocity of G on the connecting rod, which has least velocity relative to the crankshaft. So they have given location of E point only. This point they have given location and this we need to draw from the velocity diagram. So now you are going to draw this crank, then connecting rod, and this location E, which is 1.5 meter from the gudgeon pin. So this one is the gudgeon pin, and this distance is 1.5 meter. We can't show this G because if you are going to see this serial number 5, position and linear velocity of any point G on the connecting rod which has least velocity relative to the crankshaft. So this is not given. So after drawing the velocity diagram, we need to locate this G point. So you can draw connecting rod, show point E, show point P, show point B, and this O, and this angle 45. So this is first step. So I request all the students, they should draw this space diagram or the configuration diagram. They should not draw this G point. Only you can draw whatever remaining by excluding the G. Draw this space diagram. Write these steps. This step. हां डायग्राम कंप्लीट झाली अजय.
Yes, sir.
ओके. प्रथमेश प्रथमेश
Yes, sir, complete.
ओके. रेवणनाथ आदित्य आदित्य थिटे
Yes, sir.
okay. So after drawing the space diagram we need to go for the velocity diagram. So you can write step number 2. Step number 2, you should write in your notebook. Step number 2, draw vector OB perpendicular to BO perpendicular to PO to some suitable scale some suitable scale to represent the velocity of B with respect to O or velocity of B such that vector OB is equal to VBO is equal to VB is equal to 9.426 meter per second. 9.426 meter per second. So already we have calculated screen is visible.
Yes, sir.
Screen is visible. Ajay, screen is visible.
Yes, sir.
Space diagram. Space diagram is visible.
No, sir.
Wait for 1 minute. So please wait for 1 minute. 1 minute. So I will connect because. So please wait for 1 minute. Please. So due to technical reason, so please wait for 1 minute. एक मिनिट थांबा बरं का रेवन्नाथ, डिस्कनेक्ट झालं इंटरनेट, मोबाईलला चालू आहे. प्लीज वेट फॉर 1 मिनिट. There was issue with related to internet, so sorry for that. Okay, so this we have seen regarding the first space diagram. Then this one is the second step that you have written. Okay, now screen is visible, Ajay.
Yes, sir.
Okay, so space diagram already we have drawn previously. Then with the suitable scale, just by considering crank OB, we need to show the velocity vector. So for this OB, so already we have seen how to draw the velocity diagram. So for this 9.426, we need to choose the appropriate scale. So 1 centimeter is equal to 1 meter per second. That means to show this VB or VBO, we have selected the scale 1 centimeter is equal to 1 meter per second. So with the scale 9.426, we can have approximately 9.5 centimeter for the OB. So perpendicular to this. So as explained yesterday, you are going to draw one line here which is perpendicular to this OB. Okay. So OB we are going to draw. So I have shown the whole velocity diagram, but you are going to construct only this OB. So that's why only OB is written. So we need to draw one vector. So here it is OB, O, so VB, O. We can draw. This is the first vector. So draw this OB. This one is the starting point. So this VBO we have drawn parallel to this line. So only concentrate on this OB. So 1 centimeter is equal to 1 meter per second. That means this segment is having length 9.5 centimeter. In notebook मध्ये distance एवढं बसू शकतं 9.5 centimeter. Or based on your convenience, you can take different scale also. फक्त OB ड्रॉ करा.